Let's chat a bit about MongoDB. Um, so, um, MongoDB is one of a family of databases that use an alternative to SQL, right? So SQL has been around for several decades, and it's the de facto standard on how is it that we store, retrieve, manage databases. But certainly there are many other options on how we can store things. In particular, we can store things just on a plain file, right? We can serialize maybe an instance of an object to a file system, and then maybe read it from a file system and reconstitute the instance of that object. We could write it in XML, right? We can parse that XML document and then have that data that way. Right? There's certainly many alternatives on how data can be stored, retrieved, and managed. And in particular, NoSQL databases have become more and more popular in the last decade or so. And when we've seen the growth of databases, just the amount of storage that we're storing, it's just staggering, right? You pick up any phone and you just wiggle around, and it's generate a stream of data that somebody's storing somewhere, somebody's indexing, somebody's for later retrieval, and we're generating amounts of data that we're never ever going to be able to process it, right? To make any sense out of it. So we have all these new artificial intelligence mechanisms that scour our data and aggregate it and analyze it and summarize it for us, right? That automatically manage all this data to make any sense out of it, right? So that we can extract knowledge, that we can extract meaningful and usable data from this plethora of just raw data that we're generating. And so MongoDB is one of several databases that have become fairly popular lately. That is widely used. That uses an alternative to SQL. It has many of the same challenges, right? Of normalization and indexing. So a lot of the same issues that we might find in relational databases, handling transactions, and storage and whatnot. But right, it's designed to make it easy for the current use cases that we have today, the kind of applications that we're building today. A lot of the applications that we're building today are our web applications, right? Applications that are running on a browser that are connecting to any number of APIs and retrieving and aggregating data from many different data sources, right? And aggregating at the client side and pulling that data together to make a consistent application. So today we'd like to explore the use of MongoDB and how it can be used to host our data. Then we'll see how it can be made available through the use of APIs, JSON APIs, RESTful APIs that can then be accessed by anywhere on the network. All right. In particular, we'll see towards the end of the lecture, we'll create a tiny little Angular 4 client, right? That will be able to access this data through a REST. Okay. All right. So if you go to MongoDB, you can download it from here. In particular, you can look for MongoDB, the community edition. If you go to their landing page, they'll probably try to sell you their for pay versions of the internet and try to of databases, and they'll try to ask you to host their database with them with a recurring fee and whatnot. Nevertheless, there's a free version of MongoDB for the various platforms, right? So you can download that, and it's just a directory, right? As long as you can put their bin directory on your path, you should be able to just execute the server. Okay. right? And that's exactly what I've done. So once it's installed, there's a couple of executables that are of interest to us. One of them is the server itself, the database server, and the other one is the client that allows you to connect to a database and interact with it. Very much like in SQL. Also, you have the server MySQL that starts up the server, and then you have MySQL, the client, right, that you execute, and then you can interact with the database. So same thing here. We have instead of MySQL, we have Mongodb. Mongodb starts the server. I believe it's already running, and then it goes into a loop waiting for connections for clients to connect to the database. It's expecting there is a directory already created /data/db. Where it's going to store, by default, it's going to store all the database into that directory. So before you start the Mongo database server, you'll need to create that directory, the /data/db, right, off of the root of your file system. Once the server is running, you need to start. You can start the client and start interacting with the database by typing Mongo, right? Once you connect to Mongo, notice that you enter a command line interface that you can start, chatting with the database, right? Obviously one of the simplest commands you can say to show the current databases, right? Right now we have just a couple. One for the course I'm teaching, CS5610. A local one, a test, an admin, a couple projects I'm working on. Some experiments. So let's create a database for this class, right? So we can try out and experiment a couple things, right? So to create a database or schema, we can just use the command use and then the database that we want to create, right? And there it is. It just switches over to that schema. Right now, there's nothing in there, nothing stored. Typically, in a relational database, you split up the data into tables, right? You normalize it and you divide it into various tables, and the tables contain records, and the records are associated by having foreign keys and primary keys. Here, we don't have tables. The equivalent of tables here are collections. We call them collections, right? So we have to start using the right jargon here, right? So right now there are no collections. You can say show to show me all the collections, and right now there are no collections. Okay, no tables, the equivalents of tables. Now we don't call them tables since we're not really storing what we call records or rows, right? This is not a relational database, right? And I can't stress that enough. We don't have we have somewhat what it looks like primary keys, foreign keys, but it's mostly for the way we interpret it, right? There's no equivalent of enforcing relational constraints, or by that matter, there's no schema whatsoever. There's no enforcing any schema, data types, or the names of the field. This is strictly a database that allows you to store instances of objects, right? So it's an object database, right? So not a relational database, right? And in particular, it's JavaScript objects, right? Objects that are meant to be consumed by some JavaScript client, right? If this were a Java object data store, it would store it in a serialized format for Java objects, right? In Java, you could do this, right? You can ask Java to serialize a Java object instance that is running in RAM to serialize it to a file system for later retrieval. Later on, you can tell it what the file was that you stored the object, right? And then load it back into memory and reinstantiate it in memory, right? So here's it's the equivalent, okay? But instead of storing it in a binary format, right, it's stored in plain old JavaScript object notation, in JSON notation, right? Lots of curly brackets, like lots of name value pairs, right? And the names of the fields are plain text, and the values are also plain text, right? In many of the data types supported by JavaScript, right? So we have strings, numbers, dates, and whatnot, right? And arrays and objects and nested objects. Yes. So these are just plain old JavaScript objects. And there is no schema, right? Some of us that are coming from the SQL world, we would cringe at this, right? Because we would always think about, well, I'll create the schema, right? I'll create the table with the fields and the data types and whatnot. No such thing here, okay? So let's, with that in mind, let's start playing around with this. Let's create a couple of things. Let's start adding some data, modifying some data, and see what we can do. All right.